Today we want to talk about solving literal equations. What is a literal equation? Basically, it's a formula. A literal equation is a formula that has nothing but variables and, possibly pi symbols in it, as you can see on this worksheet. But it has nothing but symbols, really, to describe. There's with the exception of maybe a value that's used within that formula, there really are no symbols used, or there really are no numbers that are used when we're solving a literal equation. So let's go ahead and talk about the area of a circle. And we would need this if we were reading a word problem and it said, for instance, the area of a circle is such and such number. Let's say it's 100, just for this sake. Area of a circle is 100. Determine what the radius is. Okay, what we would need to be able to do is to put the formula into the format that solves for R, so we can put the numbers in and solve it. And that's what we want to do. So here we say, what is the area of a circle? Solve for R. So I'm going to start off by writing the formula. A equals pi R squared. And remember, I want to solve for R. So what I want to do is I want to isolate R on the side of the equal sign all by itself. That's the thing that I'm trying to find. So the first thing I can do is I can go ahead and divide both sides by pi. Okay, let's get that pi out of the way. So now I'm left with A divided by pi equals R squared. Since those pi's cancel each other out, we're left with that. But it says R squared. We want to go ahead and just have R. So we can think back to when we solved the Pythagorean theorem last year, and remember when we had a squared value, we took the square root of it. And that's what we want to do to both sides here. So what we'll have is R equals, I'm going backwards, and you could write it the other way. Remember, we have properties that say we can. The square root of A divided by pi. And I want to keep that A a capital A, because that really does tell us that the area divided by pi. Okay, so let's go ahead and talk about the volume of a pyramid. Well, this says solve for H. So if I'm solving for H, let's see here. I'm going to go ahead and erase this, so go ahead and get this written down. If you need to pause, please pause. And so it says volume equals 1/3 pi R squared H. And it says solve for H. So if we said the volume of a pyramid is all right, I paused real quick because I'm looking at this, and this is not the formula for a pyramid. That's a formula for a cone. Okay, so we have volume equals 1/3 pi R squared H. So if I want to solve this, the first thing I'm going to do, I'm going to go ahead and take care of, now it says solve for H, so I want to isolate that H on the side by itself. I'm going to take care of that 1/3 first. And to do that, I'm going to multiply both sides by the reciprocal. So I'm going to be multiplying this side by 3/1, I could say, because those would cancel each other out completely. And 3/1 is 3, so I have 3V equals pi R squared H. Okay, just doing that separately so we can see that that's why I have 3V. Okay, now what I want to do is I need to get rid of pi and R squared. I can divide this side by pi r squared. And I, of course, would have to divide this side by pi r squared. I'm doing that in order to cancel these out. Remember, any number or value divided by itself is 1. So I'm left with 3v divided by pi r squared equals h. Okay, let's go ahead and move on to the discount. Now for discount, it says S equals L minus RL. Now, and it's telling us to solve for L. Well, we have two L's there, and we've talked about like terms, and we can't combine the L and the RL because they're not like terms. But there's something we can do. We're going to factor that L out of this side of the equation. And basically by factoring, I'm talking about kind of like reverse distributive property. So I have S, and it's going to equal L times the quantity 1 minus R. Now I want you to just look at this and see what I did. I pulled that L out because I have L on this term and L in this term. I can pull that out and multiply it by everything on the inside of the parentheses. Now let's see if I was to distribute this, and I'm just going to show it over here. L times 1 minus R. If I was to distribute L times 1 is L, minus L times R is RL, or LR. Either way, remember, our order doesn't matter. That's commutative. And that's why I can do that. I'm sorry I didn't show L getting multiplied to the R as well. Now it's much easier to solve for L. All I have to do is to divide this side by 1 minus R and this side by 1 minus R. And I'm left with S divided by the quantity 1 minus R equals L. If you have any questions, comments, please go ahead and write it down here in the reflection and analysis section. And if you would please, in the bottom left, I'll put arrows for some of you, that's your left. In the bottom left of this page, please draw a heart. Thank you.